These 5 tests just prove that my API handles bad input, missing data, and a happy path. Now watch what happens if we break something. And run the test again. See? Caught immediately. Now let's revert this change and correct back our validator again. All green once again. How does one know that their app handles data correctly? And more importantly, without manually touching Postman every single time. In this video, we are going to be writing tests from scratch on a real Express API and a Postgres database. Let's go. A very common task which we do is that we make an endpoint, then we test it on Postman or Swagger for our happy path, and if it works, we create a pull request to master. That's it. Tough day at work, go home. But here's what you probably did not test. What if someone sends this? Or even this. Right now, we see that the server rejected the malformed request. But without any validation, your server will either crash with a 500 internal server error, or worse, it might query the database with some garbage. No error, just wrong. And I know this because I have made this exact same mistake before. In my first project, I was working on the server-side code, and the front-end developer at that time, a very senior person, he would just not send the payload correctly. So sometimes one of the 15 keys are missing, or maybe all the keys are there, but the data type is incorrect. I'm expecting a list, whereas what I'm getting in reality is a JSON object. What I ended up discovering was validation libraries, like Zord or Pydantic if you are using Python. These libraries allow you to define schemas and use those schemas to validate your data. The tests that we are going to write today are only going to pass if the validation works, and if the validation logic is incorrect or missing entirely, they will fail. Later, if you want to take this a step further, you can integrate such regression tests in your CI/CD pipeline. So what that will do is give you the freedom to refactor confidently. Or you can use Claude Code to change 23 files in a single commit. So long as the tests are green, you can continue to farm pull requests anyway. Now let us get our tools installed. We are going to require two packages, that is Jest and Supertest. So let's add them. So what the -d flag here is doing is specifying the fact that these are development dependencies. This will keep our production image lean. So here, Jest is something that you would call a test runner and an assertion library. Allow me to explain. So a test runner is something that will scan your source code for test files. It will run those tests and tell you what passed and what didn't pass. Assertion libraries give us the expect syntax and matches like to be or to match object to actually write our tests. Now some tools split this responsibility into multiple packages. For example, Mocha. It's a test runner, but to write assertions, it needs another package by the name of Chai. And if you want to mock something, for example, an external service, you need another package by the name of Sign-in. This is prone to version mismatches. So what Jest does is provide all this functionality for us in a single package. That is a brief overview of the Zoo JavaScript testing ecosystem is in under 1 minute. Now let's come to Supertest. Supertest, by the way, is another library which allows us to fire real HTTP requests at our Express app, but without actually starting a server. So we don't actually need to write node index.js. It will handle that for us internally. Now that we have got our packages installed, we can write a small configuration file, just config.js, which is essentially going to specify that our test environment is Node and not, of course, the browser. And in addition to this, let's also add a test script inside our package.json file that will allow us to run yarn test directly instead of writing the whole command. If we take a look at this test script, we can break this down into three parts. First node, then experimental VM modules flag, and then finally the part 2 just binary. So let's start with the experimental VM modules flag. The reason we are writing this is because as of now, Jest cannot parse ESM module syntax. And by passing this flag, we are giving the node VM module, which is what Jest uses under the hood, new APIs so that it can create execution context for files which have the import syntax, and as opposed to the require syntax that we see in CommonJS. After this, I have given the path to just binary directly because I wish to avoid ambiguity, but you can simply write just and that will work also. Now, by default, Jest is able to find all the files which have test or spec inside of them, so we don't have to write any special configuration for that. And if I run yarn test now, we can see that it is able to find all the test files that we have written. Before we write any tests, we need to talk about this file, the validator, because this is exactly the logic that we are going to be testing. This right here is Zord. Zord is a schema validation library. The idea here is simple. You define a schema and the incoming data gets passed by Zord. If it does not match the defined schema, Zord will throw an exception. Take a look at this line. We know that the track ID inside the database is a positive integer. It starts from 1. Now these three operations chained together are going to ensure exactly that. So whenever a request comes in, Zord will try to parse it. And if in case it's unable to do so, for example, the input is ABC or maybe a negative integer or a floating point decimal, it will reject it. All of that in one line, which brings us to our controller. If you look at the catch block here, you can see that we are specifically checking for any instances of Zord error. And if we find them, we are returning a 400 HTTP status code. Without this, all errors will be internal server errors, and that way debugging becomes very difficult. What we can also do specifically for internal server errors is that we can log them and return a correlation ID back to the client. So that way they can ask for help. But in case the payload is not as per our contract, we always have to return a 400 bad request. Finally, time has come we start writing our tests. We'll start with a clean slate by first importing the Jest library. And the reason we are importing Jest explicitly is because we are on ESM, and unlike CommonJS, it's not available globally. Now then, before we do anything, we must first mock our database. And it makes sense, right? Because unit tests are supposed to be isolated. We are not trying to test the database, but rather our individual piece of logic. So we will be pointing Jest mock API to our db.js file. And if we take a look at our db.js file, we can see that it's doing nothing but exporting an instance of Postgres pool class. And coming to our service layer, we are using the query method of the pool class to run raw SQL queries inside our database. So this is exactly the method that we want to mock. So coming back to our test file, inside the factory function, we will replace the query method with our own. So this jest.function here is a dummy. It does not do anything on its own. We'll be telling it exactly what to return inside each of our tests. And since pool is a default export of the file, let's put a default wrapper around this. And finally, since we are using ESM, we have to replace this mock function with the unstable mock module. What I also want you to keep in mind is this exact sequence. Mocking the database must always come first, because if we import the app before this line, it will load up the real database connection and our mock will be too late. Now that database is out of the way, we can import everything else. So let's start by importing Supertest, because that will allow us to make HTTP assertions. Then our application. App, by the way, is the name of the default export of our Express app. So we can see that here. And let's also import the pool that we just mocked. Let's also grab the query function directly so that we can make assertions on it later. Things like how many times it was called or what it returned. You might have also observed these dynamic imports with await. Once again, an ESM thing. Let's start writing tests for checking bad input now. Generally speaking, your tests are going to follow this structure. We define test using the it function, then follow it by a test description, and inside the callback we make our assertions. This test description is something that shows up in terminal output, so it's helpful to write something descriptive here. So how does this apply to our use case? Our test description can be something like returns a 400 when track ID is string. And inside the callback we are going to use Supertest to make an HTTP request to our server. This is the part that we discussed earlier. Supertest wraps our app, and instead of having us to manually start the server, it can make the request internally. Now we write our first assertion. We do that using the expect function, followed by a matcher. So what this line asserts is whenever we pass a track ID as a string to our server, we get in response a 400 HTTP status code. But we'll write an even more important assertion. So what this to have been called times matcher does is check if a function was called a specified number of times. And this makes a lot of sense, because if a request payload has already been rejected, then it shouldn't go anywhere near our Postgres, right? And while we are at it, let's await this HTTP request, put an async in front of the callback, and fix the path to our app. It's actually one directory behind. Save the file and try to run this test. All green. That's a clean win. Let's write two more tests along the same lines, just for good measure. One for negative and one for zero ID. Just copy this block, Paste it twice. Save the file and run those tests again. All green. We are on fire today. Let's write one more test for when a track is not found. And this one is different because this time we are going to enter a valid ID. 999 is a perfectly valid positive integer. Zod will let it through. But this time we are going to ask our mock to return an empty array. The mock resolved value once is a just function that returns a value for the next call only. That means that subsequent calls will require their own mock. But what this will do for us is when pool.query is called, it is going to return an empty array. Subsequently, the service will return null, and then finally the controller will also return a 404. And that's what we want to assert. And since this input is completely legitimate, the database should have been called exactly once. This proves that valid input goes all the way to the database and returns a not found if the value truly is not there. Finally, and I promise this is the last one, let's check for happy path. We tell our mock to return Iron Maiden's Fear of the Dark. And this test specifically has two assertions. First is HTTP status 200, pretty obvious. But the next assertion with the matcher to match object is particularly interesting because this matcher checks if these particular keys exist with these particular values in the response. It's not trying to match the whole object, and it's useful because your code will evolve and your API may start adding more fields into the response. For example, created at, updated at, and you don't want your test breaking each time someone does that. So let's run our test now to check if everything is alright. Brilliant. All 5 passing just as how we expected. Now let's try breaking one of these tests on purpose. Run the test again. Red. And that's the whole point. I didn't have to start the server, I didn't have to touch Postman or manually try anything. The test caught it immediately. And if I fix it back and run the test again, all green once again. You write these tests once and they run forever in your pull requests, in your deployment pipelines, etc. One final thing I'd like to note before I conclude is that while making this video I chose Jest. There is another library by the name of vtest which pairs really well with TypeScript and ESM, but I still chose Jest because it's really popular and a lot of projects, including mine, still use it. If you choose to use vtest, the API is almost the same. You can write the same syntax and get away with it most of the times. And with that, I hope this video was very fun to you. It truly was for me, and I'll see you later.